Hello, in today's lesson, we want to solve this particular question. So without wasting much time, let's start. It says that given that 2 tan 15 degrees all over 1 plus tan squared 15 degrees is equal to sine 30 degrees. And the question wants us to find tan 15 degrees, leaving our answer in a set form. Okay, so what we are going to do is we are going to do some simplification and some representation here. If we look at the question, we have been given sine 30. And sine 30 is a known value. Even if when you type it on a calculator, you're going to get sine 30 degrees to be equal to 1 over 2. It is known value. If that is the case, then again, let a variable of our choice say y equal to the tan 15 degrees. So wherever that we see tan 15, we substitute y there. If that is the case, then for the numerator, we are going to get 2 times what? Y, because that is where we are having our tan 15. So 2 times y over, we have our 1 plus, this is tan squared 15 degrees. So it means that this is going to be y squared being equal to 1 over 2. Okay, so we simplify this further, or we can do our cross multiplication. Whatever we are having here, this denominator multiplies this, and then this one 2 multiplies whatever that we are having here. So we end up getting the 2 multiplying the 2y, and this is going to give us 4y being equal to 1 multiplying indeed the 1 plus y squared. So we are going to get our 4y being equal to 1 plus y squared. This becomes quadratic equation because the highest exponent there is 2. So let's rearrange this in the order of the general quadratic equation. And let's assume that we are shifting everything to the other side. So this will be the same as minus y squared minus 4y minus 1 being equal to 0. Sorry, plus 4y here. Okay. And when we try multiplying through by -1, this will be the same as y squared minus 4y plus 1 being equal to 0. Okay, now we need to solve this particular equation. And looking at the equation there, we can't use factorization method to solve that. So it's either we use the completing of squares or we use the general quadratic formula. So let's try using the general quadratic formula here to solve this particular equation. Okay, so we are having y squared minus 4y plus 1 being equal to 0. And if we want to use the general quadratic formula, then our y will be equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Okay, now this particular equation, we have to compare this to the general quadratic equation. So if we are having our y squared minus 4y plus 1 being equal to 0, and per the general quadratic equation, which our main variable is y, supposed to be of the form ay squared plus by plus c being equal to 0. In that case, per comparing, then our a indeed will be equal to the coefficient of y squared, b is the coefficient of y, and then c is the constant term. So our a will be equal to 1, our b will be equal to minus 4, and our c will be equal to 1. So we are going to substitute these parameters into the formula. Therefore, we are going to get our y to be equal to minus b is minus 4, plus or minus square root of our b squared, so minus 4 squared minus 4a, our a is 1, then c is also 1, all over 2 times 1. Okay, so then the next thing is we need to simplify this further. So we are going to get our positive 4 because minus is going to multiply the negative there. So that will give a positive 4. Plus or minus, let's simplify what we are having under the square root sign. Minus 4 squared is going to give us 16. And this one too is going to give us minus 4 all over 2 And again, this is going to give us 4 plus or minus. We are going to be left with the square root of 12 all over 2. Now, square root of 12 can be simplified further. So, we are going to have our 4 plus or minus, and the square root 12 is going to give us 2 root 3 all over 2. Okay, so we have to simplify this further. And this is going to give us 4 over 2 plus or minus 2 root 3 all over 2. And this is going to give us 2 plus or minus root 3. The question said we should leave our answer in a set form. Okay, so we are going to get one of the y values being equal to 2 plus root 3, and our second value, that is y2, being equal to 2 minus square root 3. Don't forget that y represents tan 15 degrees. In that case, we are going to have our tan 15 degrees to be equal to 2 plus root 3, or the same tan 15 degrees being equal to 2 minus root 3, because that was our representation that let y to be equal to tan 15 degrees. So if we are now having the value for y to be equal to 2 plus root 3 or 2 minus root 3, then indeed our tan 15 degrees will be equal to that. Okay, but is it true that tan 15 degrees is equal to 2 plus root 3, or tan 15 degrees is equal to 2 minus root 3? Now let's verify that. So let's represent the 15 degrees by theta. So let's say we are going to have our tan theta is equal to 2 plus root 3. We want to find out whether theta is going to give us 15 degrees. So if we are solving for theta, then we are going to have theta to be equal to tan inverse of 2 plus root 3. And on the calculator, this is going to give us 75 degrees. That is the value for theta. Again, tan theta is equal to 2 minus root 3. Let's find theta. So we are going to have our theta to be equal to tan inverse of 2 minus root 3. And indeed, this is going to give us 15 degrees. Then it means that tan 15 degrees can't be equal to the 2 plus root 3, this particular one, because when we try solving for theta, we had this to be equal to 75 degrees, like what we are having here. Okay, therefore the correct value for tan 15 degrees is equal to 2 minus root 3. Okay, so that's where we end this particular question. Thanks for watching this video, and bye bye.